Very good morning, students. So today we are taking up a very important topic in the case of the muscle mechanics, and this is the bone muscle lever systems. So students, as we have already discussed that the tendons, they are the connective tissues which are joining the muscles to the bones. So whenever the muscles they join the bones, they form bone muscle lever systems. So first of all, we should know that what is a lever system. So actually, whenever we have to do some particular work, we have to generate some kind of force. Now, to generate a particular force, that should be the desired force, which is in relation to the load which has been taken up by a particular bone or a muscle. So the tensile force which is generated by a particular muscle, it will depend simply upon that how much load has been given to the muscle, and either this muscle will generate that particular force to take up the load, or it will fail to make that particular tensile force generation. So, and the second case, the load will not be lifted, or the work will not be done up to the 100% level. Now, if I give you a simple example of the bone muscle lever system, so it will be just like if I am taking a particular bone just like this. So suppose this is our forearm bone. So this is the humerus, and then you have the ulna and the radius. So these are the three bones. So one bone is over here, and these are the two bones. I'm just taking one particular line for two bones over here, and then we have the hand will be over this position. Now students, I'm just taking up a particular muscle which has been attached to this particular bone muscle lever system. Now, how it will form a lever system? First of all, we have to go for this. Now, suppose this is the muscle which is attached just like this. Now, this muscle is very equivalent to the bicep. So we have a bicep to lift some load which will be present over this side. So this will be the load L. So we can take it as like L. So this is a load L. So it will be lifted up into this direction, suppose, by the production of the force by the bicep. Now suppose if you need a tensile force of a magnitude 10 to lift the load L, and if your bicep is efficient enough to produce a tensile force of 10 units, then this load will be lifted up. Otherwise, you are unable to lift this particular load. Now, suppose if your muscle is producing a tensile force of 8 units, I'm just taking arbitrary units for the tensile force over here. Now, if it is producing 8 units, the load will be lifted up to some extent, but you cannot lift it up to the desired level. So the level of the load lifting will be lower than the desired level. Suppose this is the desired level, the upper line is showing you the desired level, and the load will be lifted up to this level because we are having 8 units of the tensile force. Now in the second case, if you have a sports person and this load is 100 kg, and we need a tensile force of 10 units to take this load up to the level of the desired level. So he can produce a tensile force of like 10 units or even more, like 15 units. I'm just taking an example. Now why it is producing 15 units? Because that's it, he's a sportsman. Suppose he's a weightlifter, so he can produce like 15 units or he can produce 20 units depending upon the width of the bicep. So if you have a wider bicep, then the tensile force generated will be more in that case. So you must have seen that sportsmen or the weightlifters, they have got very broad, wide muscles. So they are having more of the like PCSA or the physiological cross-sectional area, and they have more of the MCSA also. So they can produce more of the tensile forces as compared to a normal person with 8 units to lift a 100 kg load. So in this particular example, we are just taking this whole of the system. Now this system is composed of, like we have bones over here, we have the bone just over here, we have the bones over here, we have the biceps, the muscles in the center. So whole of this system is making a bone muscle lever system. Now there are two main important factors which are affecting the bone muscle lever systems. Number one, that is the point of rotation. This is a very important, you can say, the point. So this is called as the point of rotation. So this is forming the lever system. And the second point is the insertion point. So this is the muscle insertion point. So we write it as just like insertion point. So insertion point refers to the site where the muscle is attached to the bone onto the lever side. So one side is this on the top and one is the insertion point. So this insertion point is a very crucial point in this is the deciding factor that how much force will be produced by this particular bone muscle lever system. So the units produced by the tensile force by this particular bone muscle lever system will depend upon the insertion point. Now the second thing which is dependent upon the insertion point is the speed of the work. Now this is a very important factor again, that what will be the time taken to lift this particular load by the muscle lever system. So if you have a good insertion point, then the time taken will be less. This lever system will take less time to take up this particular load. Now if you have more of the load, if you have higher like loads of 100 kgs of like 150 kg, then this insertion point should be somewhere else. So I'll be discussing these 2 points in next part of the lecture. Now students, we are discussing the effect of the insertion point on the tensile force generation to lift a particular load. Now I am taking again a bone muscle lever system. You can see again the 3 bones, the humerus, ulna and radius. Now we have a load L, and now we have a muscle which is very close to the point of rotation. Now first of all, this is the point of rotation, we all know this, and the muscle is now attached very closely to this point. Now here, what is the point of insertion? So this will be the point of insertion. That means that the point of insertion, I have taken POI as the point of insertion, it is very close to the point of rotation. Now in this particular case, the insertion is called as the proximal insertion. So this is referred to as the proximal insertion of the muscle. So this is very close to the point of rotation. Now students, when this particular muscle will contract to the half of its length, now I am not just taking this particular load L as very heavy. Now I am just taking it as a book. Now everybody can lift a book with the bicep. So suppose it is requiring tensile force of like 2 units. So 2 units are required to lift this particular book. So everybody can produce 2 units. Now when the muscle will contract to the half of its length, suppose this is the half of the length of the bicep. So when it will contract to this point, the bone will reach up to this level. Suppose this is the point of rotation and the bone will just like be this. So this L, the load will be taken up to this level when the muscle will contract to the half of its length. That means it will like cover a whole lot of distance. So L will be now present at this level. So if I take the displacement, so this is the position 1, I am writing as P1. So this is the position 1 and this is the position 2 of the load. Then the position 2 will be as the result of the half contraction of this particular muscle. Now we are taking the second case. Now in this particular case, we have the point of rotation. This is the point of rotation. I should take it as like in the red color. I was taking in the red color as point of rotation. Now in this particular case, the muscle insertion point is not very close to the point of rotation. Now in this particular case, we have the muscle embedded just over here. So what will happen, that the insertion point is said to be as distal in this particular case. So we say that it is distal insertion of the muscle. Now as both they are at like higher distances, then what will happen, that when the bicep will contract to the half of its length, so this is the half of the length of the bicep, then what will happen, the load now will be, the bone will be just like in this direction and the load will be at this particular position. So here we have the P1 over here, this is the position 1 and this is the position 2 of the load. Now students, this is the case 2 and you have seen that the distal insertion point, it leads to less of the displacement, but in this particular case the strength will be more. So this is a very important point. So the strength in the distal insertion point will be more. Now this bone muscle lever system will be more stronger than the first case. So if you have Suppose if you have the proximal insertion point, so if it is proximal, the strength will be low, but the speed of the displacement or the speed of contraction, it will be high. So this is the difference between the two types of the insertion points. So I'm just drawing the case 1 again. So we have a humerus, then we have the aligned radius, and we have a distal insertion point on the above level, and now here we have the proximal insertion point. So we have very close the point of rotation and a very close point of insertion. Now in this particular case, the bone will reach up to this level, when it will contract to the half of the length. So here the displacement is more, so that means the speed will be higher in this particular case, in the lower case, but in the upper case the displacement is less, but the strength is more and the speed is less. So this is the difference between the two types of the insertion points. So you might get a question on that, what is the effect of the insertion point. So you must be going with the distal insertion points and the proximal insertion point. So I hope that you have understood the topic.